Hello everyone, welcome to Easy Math. In this video, we are going to see class 8 mathematics. In chapter 2, we are going to see in measurements. We are going to see the concept three-dimensional shapes. Okay, we have studied about these shapes in junior classes like 2D shapes and 3D shapes, isn't it, children? So first let us see 2D shapes. 2D shapes are nothing but it is given in the book itself, the outline of a coin. You take a coin. It is given, take a 2 rupee coin and draw its outline. And take a 10 rupee note and draw its outline. And take a square shaped biscuit and draw the outline on a paper. When you draw these things on a paper, the drawings on the paper, or when you draw it on the board, they are called two-dimensional shapes. Okay, and same thing, this is only outline of the coin. These are all only outlines of a rupee, 10 rupee note and the biscuit. Now, what do? You just arrange few coins, some 10 to 20 coins, you arrange one on top of the other. And you arrange some 10 rupees notes, one on top of the other. Then you arrange some 10 biscuits, one on top of the other. What do you get? See, now the shape you get is a solid shape. It is a three-dimensional shapes. It is a cylinder. This is the shape of a cuboid. This is the shape of a cube. So, these three-dimensional shapes have three measures: length, breadth, and the height. Okay, this is the length, this is the breadth, and this is the height. But when you draw the outlines of these, we can notice from this figure, they have only two dimensions, length and breadth. See, this is the side, this is the side. Here, sides are equal, so we call it a side. Here, the sides are different, so we call them as length and breadth. These figures, we cannot take and hold it in our hand. We can just draw it on the board. Also, when you cut it and take it out, it has some thickness. When that thickness comes, this circle on the board has no thickness. When you draw the outline, even in the book, it has only outline, it has no thickness. When you cut this paper and take it, when you can hold it in your hand, it becomes a solid shape. Because to hold in a hand, it has to have some thickness. That thickness is nothing but the height. Okay, children. So, these are two-dimensional shapes when you draw it in the notebook, in the textbook, in the chart paper, or in the board. And when you are arranging the same shapes, many circles together, many rectangles together, many squares together, we get three-dimensional shapes. Okay, understood? Now, let us see the common three-dimensional shapes now. Cube, cuboid. We have studied all this already. Cylinder, cone, sphere. Circle, when you take a bangle, it is a circle. And when you take a ball, it is a sphere. A cricket ball, rubber ball, football, volleyball, all those are spheres. And three more things we are going to study here. Prism and a triangular pyramid and square pyramid. See, you should know the difference between prism and a pyramid. This prism, prism has two flat surfaces on top and bottom. See, bottom is also triangle, top is also a triangle. It has faces, plane surfaces at the bottom and on the top. But in pyramid, the base is a plane surface. It can be square or rectangle or any other polygon. But all the edges of those base converge or join to a point. So the top is a point. All the edges from the base, they join at the point on top. So the top is a point. So when they end at a point, it is a pyramid. And if the base is a triangle, we call it as triangular pyramid. If the base is a square, we call square pyramid. But what is prism? You check, they don't converge at a point. Here also we have three sides, 1, 2, 3. But here you look at it, you can see the difference. 1, 2, 3 sides. This is the top face. This is the bottom face. This is the base and this is the top. Both are triangles. But here we cannot see. Can you see a triangle like this here? No. These are the left hand side, right hand side and the base. And the top is a point. So this is left, right. Top is also a triangle and the base is also triangle. So when the top and base both are faces, both are plane faces, it is a prism. And only the base is a plane figure square or a triangle, and all those end at a point on top, then it is called a pyramid. This is the major difference between prism and a pyramid. So these are the some basic, what is it, three-dimensional shapes. Okay, children? Okay, now we'll study about the faces. F for faces, V for vertices, and E for edges. Okay, you can see clearly now. This is the shape and this is the name. F means faces. V means vertices. You can see here, F for faces, V for vertices, and E for edges. These are the short forms we have. F, faces, V, vertices, E, edges. Now in a cube, let us see how many faces, how many vertices, and how many edges. So this is the cube. Cube means the length, what is it? Length, breadth, and the height are equal. Okay, this is the length, this is the breadth, and this is the height are equal. So face, each of this square shaped, square plane figure is a face. So one, how many faces? One on top, one at the bottom. 1, 2, and 3, 4, 5, 6. Shall we see once again? 1 and the base one, 2, 3, 4, 5, 6. So it has 6 faces. Edges. Next is vertices it's given. Vertices means the corners. Where the two edges meet is the vertex. So which is one, which are the vertex here? 1, 2, where the two edges meet, that is the vertex. 1, 2, 3, 4. 4 on top and 4 down. 4 at the base. 5, 6, 7, 8. So it has 8 vertices. Edges, these lines are edges. Where the two faces meet, two faces join, we get a edge. When two edges join, we get a vertex. Got it, children? Two faces meet at this face, they meet at an edge. And two edges, the meeting point of two edges is a vertex. So how many edges? 1, 2, 3, 4, 5, 6, 7, 8. And turn around here, 9, 10, 11, 12. So it has 12 edges. 1, 2, 3, 4, 5, 6, 7, 8. Then 9, 10, 11, 12. It has 12 edges. So 12 edges. Okay. Now same thing for cuboid. It has same thing. Cuboid. 1, 2, 3, 4, 5, 6 faces. Vertices 1, 2, 3, 4 and the bottom 5, 6, 7 and 8 vertices. And edges 1, 2, 3, 4 and here 5, 6, 7, 8 and on the sides 9, 10, 11, 12. 12 edges. So cube and cuboid has same number of faces, vertices and edges, but only here all the edges are of equal size. Here all the edges are of equal size. The length, breadth, height are equal, but in rectangle, length, breadth, height are different. This is the only difference, otherwise it's all same. Same way, when you see a triangular prism, it has 5 faces, 6 vertices and 9 edges. When you take a square pyramid, it has 5 vertices, 5 faces, 5 vertices and 8 edges. Now when you take a triangular pyramid, it has 3 faces, 4 vertices and 5 edges. So we can make a table. Now we are going to form a relation from this. What we are going to do? F plus V minus E. F and V, we are going to add these two and subtract the edge. Add the faces and the vertices and subtract the edge and see what we are getting. 6 plus 8 is 14. And what is 14 minus 12 is 2. Same way, here also 6 plus 8 is 14. From that 14, you subtract the number of edges. 14 minus 12 is 2. Add them. 5 plus 6 is 11. From 11, you subtract 9. We are getting 2. Now square pyramid. 5 plus 5 is 10. 5 plus 5 is 10. Minus 2. 10 minus 8 is 2. Now 3 plus 4 is 7. From there you subtract 5. 7 minus 5 is 2. So what are we getting? Faces plus vertices minus edges. Add the number of faces with the number of vertices. From that you subtract the number of edges. We always get the answer as the same. What is the answer? 2. So what is the result we are getting? F plus V minus E is equal to 2. This is the result we are getting for any polyhedron. What is the name of all these things, all these solid shapes? What is the name given to all these solid shapes? Polyhedrons. What is the name? Polyhedron. So for any polyhedron, F plus V minus E is equal to 2. And this is known as Euler's formula. Euler is the name of the mathematician. He found this relation, so it is called Euler's formula. So you can get a question like this. What is Euler's formula? It is F plus V minus E is equal to 2. This is the Euler's formula. Faces plus vertices minus edges is equal to 2. Now using these basic concepts, let us solve exercise 2.3. Okay. You can write in the book itself, children. The 3 dimensions of a cuboid. This is a cuboid. What are 3 dimensions in this? Length, breadth and the height. So the 3 dimensions in a cuboid is length, breadth and height. This is length, second dash is breadth and third dash is height. Okay. The meeting point of more than 2 edges in a polyhedron is called meeting point of 2 edges, 2 or more edges. See, which are the edges? These are the edges. This is one edge, this is one edge. These are the edges. So, how many edges are meeting here? 1, 2, 3 edges are meeting here. So, 2 or more edge where the edges meet, the meeting point is called the vertex. It's called vertex. Then a cube has how many faces? We have seen a cube has 1, bottom is 2, 3, 4, 5, 6. Top and bottom, left and right, front and back. It has 6 faces. Cube has 6 faces. The cross section of a solid cylinder is what? That is, when you cut a cylinder, what do you get? This is the cylinder. It's a cylinder. Okay. Can you see? It has 2 circular faces. Top and the base are circular faces. And this is the curved face. Okay. This is also a curved face. And you're cutting a circle. For example, it's just your cross section means we are cutting here. We are cutting it into 2 pieces here. We are slicing it here. When you slice it, what shape will you get? Can you guess? Imagine. Just you slice it here. Well, like you can get carrot, radish, all that almost cylindrical shape. When you slice the carrots, what shape you get? Yes, it is a circle. So the cross section of a solid cylinder is a circle. Then if a net of a 3D shape has 6 plane squares, then it is called 6 plane squares. The net means you have 6 squares. When you join 6 squares, when you join together, you get a cube. These are 6 squares. You get 6 separate squares. This is 1 square. This is 2, 3, 4, 5, 6. When you arrange them like this, one here, one at the side, one at the top, one at the bottom. When you put the 6 squares together, we get a cube. So, if the net of a 3D shape has 6 plane squares, then it is called a cube. Okay. Now, second is match the following. So simple. What is the shape? It is cuboid. See, this is the shape. What is it? It is a cuboid. Then this is a, just now we saw, it is a cylinder. What is it? It's a cylinder. Second one is a cylinder. And this is, I told you, it is a square base but converging into one point. When it is joined at the point, it is what? Pyramid. So this is the third one. This is pyramid. And this is when top and bottom both are plane faces, triangular face, top also triangular face, then it is called triangular prism because the face is a triangle. And base is also triangle, top is also triangle. So it is triangular prism. But if it ends at a point, it is called but the base is in the shape of a key. Can you see 4 sides? 1, 2, 3, 4. So it is a square pyramid. Okay. The next one is, which 3D shapes do the following nets represent? Each net has a different shape. There are 6 squares. You count 1, 2, 3, 4, 5, 6. When it has 6 squares, it is a cube. Isn't it? Then here we have rectangles. 1, 2, 3, 4, 5, 6. 6 squares means it forms a cube. 6 rectangles, then it is a cuboid. Okay, and what is this? We have 3 rectangles and 2 you put together. We are bringing this top, and this is the base. This is the top face, bottom face. Both are triangles, so it is a prism. And what is this? We fold this way, we fold it this way, bring it on top, bring it up, bring all the 4 triangles from side, you bring it like this, from these 2 sides, you bring it like this, and they converge at a point. So it is called a pyramid. The base is a square. You will get the square pyramid. It is a square pyramid. You will get like this. Okay, square pyramid. You'll get a pyramid like this. Square base is the square, and all these triangles meet at a point here. Okay, the 4 triangles meet at a point. So you get a square pyramid, and this you will get like this. When you fold this top and this top, bring it up, you will get a prism like this. And what is this? You take a paper, this is one rectangle and 2 circles. When you take a rectangular sheet and roll it, this is rectangle, you roll it, what do you get? Take a rectangle, this is a rectangular sheet, you roll it, what do you get? We get a cylinder. So one rectangle, top is a circle and bottom is also a circle. 2 circles and roll it from rectangle. Take a rectangular paper and roll it, we get a cylinder. So rectangle and 2 circles form a cylinder. Okay. Now next is, what is it? It is about seeing the faces. We have different views. When you see a solid shape, we have F means front view, S means side view, T means top view. So what is this? 3 views are given. What is this view? Is front view. You see, 3, 3, 3. 3 squares, 3 squares. So this is front view. And this, when 3, this is given, this is side view. 3, what is given? This is top. When you see, we see 1, 2 and 3 squares we see. So this is top view. And side, when you see, we can see 1, 2, only 3 squares. So this is side view. And look at the next one, which is, what is this? 3, you can see 3 squares. How can you see here? When you see from top, we see 1, 2, 3 squares. So this is top view. When you see this figure from top, when you stand here and see, you can see 3 squares. So this is top view. And what is this? 2 squares we are seeing. This one square and this one square. When you see from side, you can see these 2 sides. So it is side view. And what is this? 3 and 1 top. See, this 3 and 1 top. So when you see from front, we see these 3 squares at the bottom and 1 on top. So this is the front view. You can just put it. This is top, T for top, S for side, F for front. Front, top and side. And look at this. What is this? 3 together. What can you see? 1, 2 and 3. So that is side view. And coming like this, like Z. 2, 3 and 2. So that is front view, F. Now 3, again, when you see from top, we see 2 boxes and this box. So when you see 3 boxes, it is top view. Okay, these are the different views of a solid shape. We have front view, top view and side view. Okay, interesting now, children? And the next is very easy, children. It is verify Euler's formula. We have studied Euler's formula. What is the Euler's formula we studied? It is given verify Euler's formula. Verify means Euler's formula, you should remember, F plus V minus E is equal to 2. Okay. So if you add number of faces plus number of vertices minus number of edges, if you're getting the answer 2, then the Euler's formula is true. If you're not getting 2, then it is not true. Okay, now let us add 4 plus 4, 8. 8 minus 6 is 2. So Euler's formula is true for the first one. Add now 10 plus 6 is 16. From 16 minus 12, what is 16 minus 12? Is 4. So Euler's formula is not true. If you get 2 only, this relation is true. Okay, so this is false. Then 12 plus 20, how much? 22. So 12 plus 20 is 32, sorry. 12 plus 20, 32. 32 minus 30 is 2. So Euler's relation is true. Then 20 plus 13, how much? 20 plus 13 faces plus vertices. 20 plus 13 is 33. 33 minus 3 is 3. So this is false. Why it is false? Because in the relation, your answer has to be 2. If it is the number other than 2, then it is false. Okay. Now 32 plus 60. How much it is? 32 plus 60. Faces plus vertices. 92. 92 minus 90 is 2. So that is true. So verify the Euler's relation means, yeah, faces plus vertices minus edges. Your answer should be 2. If it is 2, the Euler's formula is true. If it is not 2, then it is false. Okay. So with this chapter comes to an end, and we'll see the next chapter, algebra, in the next video. Thank you all for watching. Thank you, children.